So let's look at this problem again. If you remember, we had a field this was 90 and this was 45 meters, and we have two persons starting here together, and they are going around this field, let's say this way. And the question was the following: given that they don't go at the same speed, then one of them will be soon ahead of the first one, and at that pace, at a certain time, the person that goes faster will go around, appear in the back of the other walker or runner, and then catch up with that person. The question was, where around the field the second runner will catch up with the first one? Basically, that's the problem. So what we will do, as usual, we name all the parameters that will be used in solving this problem. And the approach is to write all the relationships we know between these parameters, and that should help solve this problem. So, this being said, let's go ahead and look at this thing closer. So, one person will be called M, and the other person will be called small m. Now, the first person will have what we call a speed. So the speed will be like S M, and of course for the other person the speed will be S small m. When the second person here catch up, it means it has done the anti-field first, come in the back, and catch up with runner number one. The distance, total distance covered by any of the runner, distance m, will always be time of m multiplied by speed of m. And for the other, the distance covered will be equal to the time of m multiplied by the speed of m. So far, this is clear. So far, this is clear. Okay. So now, we say this. When we are on this field, and the person number 2 and number 1 have started here, like we showed earlier, at some point, one person will be here. Let's just say here. And this will be M. So basically, our problem is after the second runner goes all around and comes back, we just want to know what will be this distance. So to know what this distance will be, we just need to know how long it will take runner number 2, which is small m, to do the anti-field. Once we know that time, we can first calculate during that time what distance did runner number 1, big M, what distance did it cover during that time when runner small m was going around the field to catch up behind. Okay, here again we write the relationship. We will say that the following. We will say the total length of the field, the perimeter, okay, that we learned it, perimeter is 45 plus 90 plus 45 plus 90. But for now, we just call it P, like perimeter. So the time to do the anti-perimeter, T of small m, will be equal to the perimeter divided by the speed. Therefore, during that time, we want to know what distance did runner big M travel. Well, we say the distance traveled by big M will be equal to the time we calculate multiply by the speed of big M. Because like we know, distance is always the time multiplied by the speed. And here, the time we are talking about is how long it took small m to go around the entire field first, and see ahead of him runner big M still walking. So which means we did what we did. We take the time that needed by small m and we calculate how many meters did big M travel during that time. That is why here we have time of small m, because the time it takes to go around the entire field. In other words, to run the distance of P, right, that's entire lap, and we multiply by the speed of big M because we want to know the distance covered by big M. That's why we use the speed of big M here.